Okay, welcome to another video. I'm going to try to prioritize reading the book a bit more this time. Last time I spent a lot of time in the lab, which I think was time well spent. I set up LLDP on Juniper, Aruba, and then a brand new device I'd never used before, OpenVSwitch, which is just basically a program for just a basic Linux box where you can use it as a router or a switch. All you got to do is install. You can do like an apt-get install and open OpenVSwitch, and just any Linux box you have, you can turn into a router or a switch. So you can really save some money using that just by like building your own PC, or like so what is it? Open, and I'm already getting distracted here. I wanted to focus more on that, but let's take a little bit of a dive into OpenVSwitch, because I think this is a really good solution for environments you might find yourself in, where you need to design or architect a network just on an absolute shoestring. They really don't have much money at all to work with. I think this is probably a good option, OpenVSwitch. Let's take a look at what kinds of hardware this can be added to. So, well, anyway, even without knowing the savings you could get by using hardware with this, you already have a savings in using this open source, because oftentimes you need to pay for licenses to use like Cisco iOS or Juniper OS for a business on your network. So this can save you costs just already on that. But what I'm looking for is kind of a reference or a documentation about like what kinds of hardware this is compatible with. And I don't see anything about that yet. So I wish that were more clear just initially in the documentation. This is kind of unclear what this can what hardware this can be used on. I guess this FAQ useful. It doesn't dump hardware switch. Open the hardware switch and limitations. But I would think, let's see here. So Linux, let's Google for LinuxSwitch. See, we're just gonna get, oh, here we go. Is this it? It's being introduced by Mellanox, runs on. Now, does this use that open source? See, I feel like you can build your own. Build a network Linux or switch from scratch. Yeah, I feel like you could just build your own switch and then run OpenV switch on that, and I think that could save you a lot of money doing that. But of course, it requires much more technical expertise to do that than to just buy something that comes in a box all in one piece and that you don't have to assemble yourself. Let's try this. Let's try going. Okay, here we go. Open source Ethernet switch in the palm of your hand. Ah, perfect. Ah, here we go. So now these look like Wi-Fi enabled microcontroller, blot box, the switch blocks. Make networks wired again. Wi-Fi. Okay, I'm not sure what this is all about. The days of wired networking are far from over. So you can see dish Ethernet. There's still plenty of wired plug-in, but bot blocks. This is an Ethernet switch. There's no Ethernet ports on here. These aren't RJ45 form factor. Like this one, that looks like more of an RJ11. Like that's not, because an RJ45 connection. Oh, I thought I had a cable laying around. It looks like I don't. Yeah, let's take a look at switch blocks or bot blocks. Oh, cool. This is really cool. I'm glad I found this. This is interesting. So yeah, this could be your savings. I mean, I don't know how reliable this is, but if you're on an absolute shoestring budget, you could get the standard series, and then you can get a blot box. You can even get gigabits. Yeah, so $125, and you get what do you get? Five ports, gigabits. Now the ports are really confusing me here because clearly you can't use RJ45. You've got to use. It almost looks like. Oh, okay. Here, this is good news. It actually comes with cables. So yeah, you can use. Perfect. Okay, yeah, you get RJ45 connections because it comes with these special cables. So the special cable plugs into your gigablocks here, and then you can use the other end of the cable because it has just standard RJ45 connections to connect to any other kind of gear. So okay, that makes sense. And it looks like the cables come with it. Do they, or do you have to pay extra for the cables? Aha, here we go. All Pico Blade to RJ45 cables included. So this looks like a really awesome thing. I actually might want to just build like a network lab out of this. I mean, once you got GNS, it doesn't matter. But this is really cool. I would probably even like use this like for like a home network. Like if I were to buy a house or something, like I recommend people just use this because you save a lot of money. And yeah, so I'm really glad I found this. I'm gonna put this somewhere. But ooh, it looks like they've even got. I mean, to be honest, like for a home network, I want 10 gig. I just want 10 gig everywhere because I'm a network engineer. But I mean, for what is this? $50 for the cheap one. It's $75 for a 100 megabyte connection to a connection out to. Yeah, so you get 10 100 megabyte ports, and your connection to your ISP if you're lucky, you gotta have fiber connection that's 1 GB. So the uplink to this is going to be so if you were to have 10 gig and not a 10 gig connection to your ISP, you wouldn't see the difference when it comes to your public internet traffic. But for me, I want like a security camera system, like deep learning, like I want to really kind of spend a lot of money on projects that'll just never get completed. But yeah, okay, that's going to be the end of this. This was kind of a fruitful, and then this would I think you'd be able to install OpenVSwitch on something like this. So this is a really low cost solution to even like a small business network. If you just hired as a contractor to even for like a school system or something like that, or like a small like classroom, a smaller school, and like you get hired as a contractor, and basically they say, we don't care what you do as long as you do it as cheap as you can do it. And you're like, okay, well, let's use bot boxes, and it's going to cost you $75 for a Ethernet switch with 5 100 megabyte ports, which is probably fine for a bunch of like workstations or like something like that. Let's see how much that would cost you for anything else. Oh, well, never mind. This is $6. See, that's what I thought. Like, I was actually thinking like that was kind of a high price for that. Honestly, I was because like a Raspberry Pi is like $25, like $5 now. So like, honestly, like I wanted to look this up before I moved on from talking about this, because this actually seemed like really high. So I'm just confused why this costs so much. This actually seems really expensive. So you've got automatics, that's good. You've got see this is like, you know, everything about this is really crummy. Like these here, like this probably has PPOE. But this has 5 gigabit ports, so it's got yeah, I don't. Oh yeah, here you go. You add the PPOE to it, and now you're still paying less. You're paying $50 versus $75. So I guess I don't get it. I don't understand BotBlox boards. They seem a lot more expensive. But yeah, so I guess I really just don't get it. I wish I understood more, because you can just buy like, you know, any one of these, and it's going to cost you a lot less. And then you can even get PPOE on it, so you can do like phones like on it, or like. So yeah, I just don't get it. But let's move on. I'm still gonna make note of this though. I'll include it in the notes for this video, just in case anyone's interested in this. But I will say I don't get it. I thought it was gonna be exciting because it was gonna be like a Raspberry Pi, but for networking gear. But that's really not what it is, because they're charging like $300 for one of these. So like, I don't understand why they're so expensive, especially when they just seem like, honestly, like pretty low quality switches. I mean, I guess it's because they're so small. Like, so if you were building like a special application where like you needed a really small switch, like this would be important. But like, I guess I don't understand Oh, I see. So yeah, okay. I think this is not for like low cost applications. Yeah, so this is like for a drone or a robot. So this is actually like, yeah, and that's a bot block. So bot means for robots. So I had this completely wrong. What I thought this was a kind of low cost Raspberry Pi learn networking thing, or like build a network for cheap. But it's actually the opposite of that. It's pay kind of a fair rate, whatever, but get something that can be put onto a robot, a drone, something like that, and used for those kinds of purposes. So it's not necessarily meant to be cheap. It's just meant to be really small, so it can fit on a robot. So you know what? I guess I'm not gonna link to this because I just don't think. Yeah, I don't think that's necessary. I wish they would like explain themselves a little bit better. I mean, I guess it makes sense. It's for robotics. If you know a lot about robotics or you need to do robotics, you would know if you needed this or not. I don't do robotics, so I don't understand why I would need this, because I don't need it. Alright, so let's move on. Okay, so we've got the first thing I'll do is make sure that the previous bookmark is accurate. So we're going to change the current bookmark here to the previous bookmark. There we go. So previous bookmark is good. All right, and this is the same as the current bookmark. All right, so we'll just waste no further time. Already wasted almost 20 minutes, and read the book. So pseudocode. What are we going to need? When we build our first API endpoint, we know we're going to have some code that looks more or less like the following. Now this is an API endpoint. I'm not sure if we're going to need something like that. I mean, I guess we can communicate with the switches using an API endpoint, but I don't know. We've used Flask because it's lightweight, but you don't need to be a Flask user to understand this book. In fact, we'll show you how to make your own choice of framework a minor detail. We'll need a way to retrieve batch info from the database and instantiate our domain model objects from it. And we'll also need a way of saving them back to the database. Gubbins is a British word for stuff. You can just ignore that, it's pseudocode. Okay, Gubbins. Applying the DIP, which is dependency inversion principle, to data access. As mentioned in the introduction, a layered architecture is a common approach to structuring a system that has a UI, some logic, and a database. See layered architecture, presentation layer, business logic, database layer. Remember that from before. Django's model view template structure is closely related, as is model view controller, MVC. In any case, the aim is to keep the layers separate, which is a good thing, and to have each layer depend only on the one below it. But we want our domain model to have no dependencies whatsoever. We don't want infrastructure concerns bleeding over into our domain model and slowing our unit tests or our ability to make changes. Instead, as discussed in the introduction, we think of our model as being on the inside and dependencies flowing inward to it. This is what people sometimes call onion architecture. See onion architecture. Okay, so here's onion architecture. It's different because instead of, now that's interesting. I guess I would consider this more of an onion architecture because we have overlapping layers, but here this is more like sandwich architecture than onion architecture. It almost seems like a misnomer. I'm not sure why it's called that. Is this ports and adapters? If you've been reading about architectural patterns, you may be asking yourself questions like this. Okay, let's see what question. Without looking at that, let's see what kind of question I can think of. I don't know. Let's just read it. Is this ports or adapters? No, I was not thinking that question. Is it hexagonal architecture? I was not thinking of that question either. Is that the same as onion architecture? I was not thinking of that. What I was thinking was, is onion architecture an appropriate term for something that looks more like a sandwich than an onion? What about the clean architecture? Wasn't thinking about that. I didn't know architecture could be clean or dirty. What's a port and what's an adapter? Wasn't thinking about that either. Why do you people have so many words for the same thing? I wasn't thinking of that either. So I'm kind of, this leads me to kind of wonder if this is the right book for me. I hate to just switch book to book to book to book to book. So let's just keep going on this. But I think I might have found a book that is just a little bit beyond me and a little bit out of scope with what I actually want to learn. So I actually might be better off going back, because I've got 2 more books that I was reading that I've abandoned, and I might be better going back to them eventually. I've got the Python for DevOps book that I abandoned because just the chapter was not good, but the rest of the book, the beginning of the book was absolutely perfect and valuable. I really liked it. So I could go back and keep looking at this. And then I also abandoned this book, but it looks like, but this book was actually talking about things that were completely relevant and I was really happy to learn about. So this is the book that kind of, I really think if I abandoned a book too early, it definitely would be this one that I abandoned too early. Alright, but for now, let's keep reading this, and I'll think about maybe continuing those series instead of this one the next time I make another video. Although some people like to nitpick over the differences, all of these are pretty much names for the same thing, and they all boil down to the dependency inversion principle. High-level modules, the domain, should not depend on low-level ones, the infrastructure. We'll get into some of the nitty-gritty around depending on abstractions and whether there is a Pythonic equivalent of interfaces later in the book. See also what is a port and what is an adapter in Python. Reminder, our model. Let's remind ourselves of our domain model, see our model. An allocation is the concept of linking an order line to a batch. We're storing the allocations as a collection on our batch object. Let's see how we might translate to a translate this to a relational database. The normal ORM way model depends on ORM. I don't know what that is. Object relational mappers. These days, it's unlikely that your team members are hand-rolling their own SQL queries, which I don't know what SQL stands for, but it's a database language. I think it's search query, structured query language. I got the Q right. Instead, you're almost certainly using some kind of framework to generate search query language, SQL, for you based on your object models. These frameworks are called object relational mappers, ORMs, because they exist to bridge the conceptual gap between the world of objects and domain modeling and the world of databases and relational algebra. The most important thing an ORM gives us is persistence ignorance. The idea that our fancy domain model doesn't need to know anything about how data is loaded or persisted. This helps keep our domain clean of direct dependencies on particular database technologies. But if you follow the typical SQL Alchemy tutorial, you'll end up with something like this. So this is structured query language, Alchemy. Let's take a look at that tutorial. I think I might add that to my seal also. I'm just not very good with SQL. So this could be interesting for me to follow, because I know the Flash tutorial was like really valuable. Oh, I don't think that's how you spell alchemy. Alchemy. Yeah, because I pronounce it alchemy, but I think it's pronounced alchemy. I thought it was pronounced alchemy. Alchemy. How is it pronounced?
Alchemy.
Oh, it is pronounced alchemy instead of alchemy. Yeah, that's not pronounced right. Sometimes I wonder if like we should just stop pronouncing words like differently than how they're spelled. If we should just start standardizing English or like modernizing English, and just like instead of just repeating, you know, the same, like kernel, like we should stop saying kernel. Yeah, I don't even know how to spell kernel. Yeah, like COLONEL. Like there's no R in kernel.
Kernel.
Yeah, kernel. Like we should call it a colonel. Like I just don't understand why we don't call it a colonel, and I don't think it would change anything to call it a colonel, except people could actually spell the word. All right, so yep. So I'm gonna add a hyperlink to this tutorial, and then this will be a further reading, which we've also already got quite a bit of that. Okay, so you'll end up with something like this at the end of the tutorial. You know what? I think I am gonna try to put that into action. So let's pull up the GNS3 lab that I've got going. Power up the topology. I should really have my camera somewhere else. Okay, so we're powering up all devices, and then we're going on here, and we're gonna try to get that Alchemy code to go vroom. That's gonna be a catchphrase on this channel, because that's basically just always what I want, is I want things to go vroom. So like, making it go vroom is basically the tagline to this channel. You don't need to understand SQL Alchemy to see what our pristine model is now full of. To see that our pristine model is now full of dependencies on the object relational model. What did that stand for again? Object relational mappers, and is starting to look ugly as hell besides. Can we really say this model is ignorant of the database? How can it be separate from storage concerns when our model properties are directly coupled to database columns? Django's ORM is essentially the same, but more restrictive. If you're used to using Django, And the preceding declarative SQL Alchemy snippet translates to something like this. The point is the same. Our model classes inherit directly from ORM classes, so our model depends on the ORM. We want it to be the other way around. Django doesn't provide an equivalent for SQL Alchemy's classical mapper, but see Appendix Django for examples of how to apply dependency inversion and the repository pattern to Django. Okay, so we're going to start with the terminal here, and then we're going to go to documents. There we go, and we'll go into the code along repo. So this is now a repository. I have a virtual environment in here, but instead of enabling the virtual environment, I think what I'm going to do is open Visual Studio Code to this folder. We can do that with code dot, and that'll open it to this folder. I think we will see. Yep, so we're opened to this. Okay, so let's close that, and then switch down here. We'll switch over to. Oh, come on. There we go. Perfect. That is good. So now we can activate the virtual environment. Oh, and it's going to be bin instead of scripts. Okay, so now I've got the virtual environments activated. So I kind of want to see if I can get this. No, you know what? They're not going to give the whole code, so I'm not gonna do this. Let's just keep reading. That's what I want to prioritize for this video, is getting through reading. Inverting the dependency, ORM depends on model. Well, thankfully, that's not the only way to use SQL Alchemy. The alternative is to define your schema separately and to define an explicit mapper for how to convert between the schema and our domain model, what SQL Alchemy calls a classical mapping. Number one, which we see here, the ORM imports or depends on or knows about the domain model and not the other way around. Number two, which we can see here, we define our database tables and columns by using SQL Alchemy's abstractions. Number three, which we see here, when we call the mapper function, SQL Alchemy does its magic to bind our domain model classes to the various tables we've defined. The end result will be that if we call start mappers, we will be able to easily load and save domain model instances from and to the database. But if we never call that function, our domain model classes stay blissfully unaware of the database. This gives us all the benefits of SQL Alchemy, including the ability to use Almbrick for migrations and the ability to transparently query using our domain classes, as we'll see. When you're first trying to build your ORM config, it can be useful to write tests for it, as in the following example. Number one, which we see here, if you haven't used PyTest, the session argument to this test needs to be explained. You don't need to worry about the details of PyTest or its fixtures for the purposes of this book, but the short explanation is that you can define common dependencies for your tests as fixtures, and PyTest will inject them to the tests that need them by looking at their function arguments. In this case, it's a SQL Alchemy database session. And that's all we're gonna note. You probably wouldn't keep these tests around, as you'll see shortly, once you've taken the step of inverting the dependency of ORM and domain model. It's only a small additional step to implement another abstraction called the repository pattern, which will be easier to write tests against and will provide a simple interface for faking out later in tests. But we've already achieved our objective of inverting the traditional dependency. The domain model stays pure and free from infrastructure concerns. We could throw away SQL Alchemy and use a different ORM, which is a, I don't remember what an ORM is. Object Relation Manager? Was that it? Object Relational Mapper. Or a totally different persistent system, and the domain model doesn't need to change at all. Depending on what you're doing in your domain model, and especially if you stray far from the object-oriented paradigm, you may find it increasingly hard to get the, I just looked it up, object relation mapping, I think, to produce the exact behavior you need, and you may need to modify your domain model. As so often happens with architectural decisions, you'll need to consider a trade-off. As the Zen of Python says, practicality beats purity. At this point though, our API endpoint might look something like the following, and we could get it to work just fine. So we don't have any numbers here. Introducing the repository pattern. The repository pattern is an abstraction over persistent storage. It hides the boring details of data access by pretending that all of our data is in memory. If we had infinite memory in our laptops, we'd have no need for clumsy databases. Instead, we could just use our objects whenever we liked. What would that look like? Import all data, my data. Okay. There we go. Even though our objects are in memory, we need to put them somewhere so we can find them again. Our in-memory data would let us add new objects, just like a list or a set. Because the objects are in memory, we never need to call a .save method. We just fetch the object we care about and modify it in memory. The repository in the abstract. The simplest repository has just two methods. Add to put a new item in the repository, and get to return a previously added item. We stick rigidly to using these methods for data access in our domain and our service layer. This self-imposed simplicity stops us from coupling our domain model to the database. Here's what an abstract database class, ABC, for our repository would look like. Python tip. abc.abstractMethod, that's a decorator, is one of the only things that make ABCs actually work in Python. Python will refuse to let you instantiate a class that does not implement all the abstract methods defined in its parent class. Raise not implemented error is nice, but it's neither necessary nor sufficient. In fact, your abstract methods can have real behavior that subclasses can call out to if you really want. Abstract base classes, duck typing, and protocols. We're using abstract base classes in this book for didactic reasons. We hope they help explain what the interface of the repository abstraction is. In real life, we sometimes found ourselves deleting ABCs from our production code because Python makes it too easy to ignore them, and they end up unmaintained and at worst misleading. In practice, we often just rely on Python's duck typing to enable distractions. To a Pythonista, a repository is any object that has add thing, and get ID methods. An alternative is to look into PEP 544 protocols. These give you typing without the possibility of inheritance, which prefer composition over inheritance fans will particularly like. What is the trade-off? You know, they say economists know the price of everything and the value of nothing, while programmers know the benefits of everything and the trade-offs of nothing. Whenever we introduce an architectural pattern in this book, we'll always ask, what do we get for this and what does it cost us? Usually, at the very least, we'll be introducing an extra layer of abstraction, and although we may find it will reduce complexity overall, it does add complexity locally, and it has a cost in terms of the raw numbers of moving parts and ongoing maintenance. The repository pattern is probably one of the easiest choices in the book, though if you're already headed down the DDD and dependency inversion route. As far as our code is concerned, we're really just swapping the SQL Alchemy abstraction session.query batch for a different one, batches_repo.git, that we designed. We will have to write a few lines of code in our repository class each time we add a new domain object that we want to retrieve. But in return, we get a simple abstraction over our storage layer, which we control. The repository pattern would make it easy to make fundamental changes to the way we store things, see appendix_CSVS. And as we'll see, it is easy to fake out for unit tests. In addition, the repository pattern is so common in the domain-driven design world that if you do collaborate with programmers who have come to Python from the Java and C# worlds, they're likely to recognize it. Repository pattern illustrates the pattern. Okay, so here we've got the application layer. So it kind of looked like it did before, but here we've got domain model objects in between application layer and repository. As always, we start with a test. This would probably be classified as an integration test since we're checking that our code, the repository, is correctly integrated with the database. Hence, the tests tend to mix raw SQL with calls and assertions on our own code. Tip: unlike the ORM tests from earlier, these tests are good candidates for staying part of your code base longer term, particularly if any parts of your domain model mean the object relational map is non-trivial. Okay, so here we've got some explanations. Repo.add is the method under test here. Number 2, we keep the .commit outside of the repository and make it the responsibility of the caller. There are pros and cons for this. Some of our reasons will become clearer when we get to chapter 6. I'm not sure if the reasons are going to become more queer, but I guess we'll have to read in chapter 6 if that's the case. And number 3 down here, we use the raw SQL to verify that the right data has been saved. The next test involves retrieving batches and allocations, so it's more complex. Great, so likewise we've got some numbers here, session.execute. This tests the read side, so the raw SQL is preparing data to be read by the repo.git. Number 2, we've got right here. We'll spare you the details of insert_bash and insert_score allocation. The point is to create a couple of batches, and for the batch we're interested in, to have one existing order line allocated to it. Number 3, oh, it looks like this is another number 2. I'm not sure why number 2 has 2 items. But here's number 3. And that's what we verified here. First, assert equals checks that the types match. and that the reference is the same because, as you remember, batch is an entity and we have a custom underscore dunder EQ for it. Number 4 is here. So we also explicitly check on its major attributes, including _, allocations, which is a Python set of ordered line value objects. Whether or not you painstakingly write tests for every model is a judgment call. Once you have one class tested for create, modify, save, you might be happy to go on and do the others with a minimal round-trip test, or even nothing at all, if they all follow a similar pattern. In our case, the ORM, which I believe was Object Relational Mapping, I actually don't remember if it stands for that right now, but let's just keep going. Config that sums up the _, allocations set is a little complex, so it merited a specific test. You end up with something like this. Okay, we're just going to move on. And now our Flax endpoint might look something like the following. Alright, so now we're on to the exercise. Exercise for the reader. We bumped into a friend at a domain-driven design conference the other day who said, I haven't used an object relational mapping in 20 years. The repository pattern and an ORM both act as abstractions in front of raw SQL, so using one behind the other really isn't necessary. Why not have a go at implementing our repository without using the ORM? You'll find the code on GitHub. We left the repository tests, but figuring out what SQL search query language to write is up to you. Perhaps it'll be harder than you think. Perhaps it'll be easier. But the nice thing is the rest of your application just doesn't care. Building a fake repository for tests is now trivial. Here's one of the biggest benefits of the repository pattern. So we can see we've got a fake repository here. Because it's a simple wrapper around a set, and all methods are one-liners. Building a fake repo in tests is really easy, and we have a simple abstraction that's easy to use and care about. So here we were initializing this class into an object called fake_repo. You'll see this fake in action in the next chapter. Tip: building fakes for your abstractions is an excellent way to get design feedback. If it's hard to fake, the abstraction is probably too complicated. What is a port and what is an adapter in Python? You don't want to dwell on the terminology too much here because the main thing we want to focus on is dependency inversion, and the specifics of the technique you use don't matter too much. Also, we're aware that different people use slightly different definitions. Ports and adapters came out of the object-oriented world, and the definition we hold onto is that the port is the interface between our application and whatever it is we wish to abstract away, and the adapter is the implementation behind that interface or abstraction. Now, Python doesn't have the interfaces per se, so although it's usually easy to identify an adapter, defining the port can be harder. If you're using an abstract base class, that's the port. If not, the port is just the duck type that your adapters conform to and that your core application expects, the function and method names in use, and their argument names and types. Concretely, in this chapter, abstract repository is the port, and SQL, Alchemy repository, and fake repository are the adapters. Wrap up. Bearing the rich Hickey quote in mind, In each chapter, we summarize the costs and benefits of each architectural pattern we introduce. I wish they would say the name of the pattern. We want to be clear that we're not saying every single application needs to be built this way. Only sometimes does the complexity of an app and domain make it worth investing the time and effort in adding these extra layers of indirection. With that in mind, repository pattern and persistence arrogance, the trade-offs, shows some of the pros and cons of the repository pattern and our persistent ignorant model. Okay, so the pros of the repository pattern and the persistent ignorant model are we have a simple interface between persistent storage and our domain model. It's easy to make a fake version of the repository for unit testing or to swap out different storage solutions because we've fully decoupled the model from infrastructure concerns. Writing the domain model before thinking about persistence helps us focus on the business problem at hand. If we ever want to radically change our approach, we can do that in our model without needing to worry about foreign keys or migrations until later. Our database schema is really simple because we have complete control over how we map our objects to tables. The cons of the repository pattern and persistence ignorance are that an ORM object relational mapping already buys you some decoupling. Changing foreign keys might be hard, but it should be pretty easy to swap between MySQL and PostGRES if you ever need to. Maintaining ORM mappings by hand requires extra work and extra code. Any extra layer of indirection always increases maintenance costs and adds a WTF factor for Python programmers who've never seen the repository pattern before. Domain model trade-offs as a diagram shows the basic thesis. Yes, for simple cases, a decoupled domain model is harder work than a simple ORM/active record pattern. Tip: if your app is just a simple CRUD, create, read, update, delete, wrapper around a database, then you don't need a domain model or a repository. But the more complex the domain, the more an investment in freeing yourself from infrastructure concerns will pay off in terms of the ease of making changes. So cost of changes, complexity of business logic, business domain logic. Here's a domain model trade-offs as a diagram. So as the business and domain logic becomes more complex, and as the cost of changes go up, we can see that a domain model with repository pattern just increases linearly. So by the time you get all the way here, super complex business logic, super high costs of changes, it's still your cost of changes are still relatively low compared to the active record/OSM. In fact, since this is exponential, there's a point where you actually can't have more complex business or domain logic because your cost of changes are just so great that there's no sense in making any more changes at all. And even if you wanted to make changes, the cost would be so high you just couldn't afford to make them. Our example code isn't complex enough to give more than a hint of what the right-handed side of the graph looks like, but the hints are there. Imagine, for example, if we decide one day that we want to challenge allocations to live on the order line instead of on the batch object. If we were using Django, say we'd have to define and think through the database migration before we could run any tests. As it is, because our model is just plain old Python objects, we can change a set to being a new attribute without needing to think about the database until later. Repository pattern recap. Apply dependency inversion to your ORM. Our domain model should be free of infrastructure concerns, so your ORM should import your model and not the other way around. The repository pattern is a simple abstraction around permanent storage. The repository gives you the illusion of a collection of in-memory objects. It makes it easier to create a fake repository for testing and to swap fundamental details of your infrastructure without destructing your core application. See Appendix CVS for an example. You'll be wondering, how do we instantiate these repositories, fake or real? What will our Flask app actually look like? You'll find out in the next exciting installment, the service layer pattern, but first a brief digression. So we're going to stop here. This is a brief interlude on decoupling and abstractions. So we'll put our link here, and then we'll edit our current bookmark. Okay, and just test that, make sure it brings us to our place. Perfect. Okay. And then, yeah, I didn't take any notes in this one. I don't know. I didn't really get a lot out of this one. I don't know what a fake repository is or why it's necessary. I guess I would like to learn more about SQL, but I don't think just going through the SQL database is the right way to do it. I think a better way is to actually go through these courses I have, because I paid for them and I just never did them. So I think that's going to be the best way, because I can get more value out of the courses I already paid for, and I'd be more like on Rails then, and I think I'd be getting better education and experiences. So here's one I could do that I haven't done yet all the way through. You can see I've only done half of the welcome, so that's obviously not good at all. But some of these are a bit too easy for me. Unfortunately. But I think this is going to be a better way, and you can see this is these are really great courses, and I haven't done them at all. Yeah, I've got a lot of courses here. That's because I at one point just went through all the free courses and enrolled in all of them. But I do have some paid courses on here as well. So I think that's going to be better for me. Yeah, this one, and then these two for sure. This is so much better. Okay, so unfortunately this might be one of the last videos in this series for a while. We'll see. It's just kind of all over my head, and not only that, it's what's the word? Out of scope with what I want to learn. So I hate to just keep bouncing from subject to subject and never actually spending enough time on any single thing. But that's definitely going to be it for this video. So I'll see you in the next one.